Hi guys, welcome to my YouTube channel. I'm your tutor, Mr. Baraka, and today I want us to look at part 3 of our revision in chemistry as you prepare for Kcse chemistry paper. Question 1 says give systematic names of the following compounds given below. Look at the compound that is given there. You can see very clearly there's a CH3, CH2, then there's COOH, and we said every time you see COOH like this one it means an alkanoic acid. So you simply count the number of carbon atoms, 1, 2, 3, and because there are 3, it is prop, so it is supposed to be propanoic acid. So prop because there are 3, and then you end up with what? You end up with the suffix noic because it's an alkanoic acid. So the answer is propanoic acid. And then this one, you can even open up the structure. The first carbon has 3 hydrogens like that. The second carbon has 2 hydrogens. The third carbon, 2 hydrogens, and then OH. We said if you see OH attached there, it means this one is an alkanol. So if you look at this one, it has 3 carbon atoms. So the functional group is OH. All. But now we said when you are naming alkanols, you have to give the position of the OH. Where is the OH? Which carbon number? So if you look at this one, it will be propan, and then the position of the ol or OH is shown. And is what? Propan 1-ol. So if you just write propanol, it is wrong because the question says you give the systematic names. So it is propan 1-ol. This is the correct answer for that part. And then the next part says that draw and name the structure or the structural formula of the compound obtained when the compounds in A, Roman 1 and Roman 2 above react. So when you have the acid and the alkanol reacting, what do you get? We said you get an ester. And how is it done? We always said this, that from here, the OH, this OH here, is the one that is used in the reaction. So we remove this one, and then the H here, the acid gives us the H, and then the alkanol gives us OH. So it means we shall not have OH at the end. We remain with this part, the alkyl part, which is propyl. And then when we remove the hydrogen, it means then this one can come and combine there. So it is very simple. You just start with what is there, the structural formula. So you have to open the bonds like that, and then you come to the next part like that, and then you come to the other one, you have that, and then that. We had a hydrogen here, the hydrogen has been removed. So this one and this one will give us water. So when I remove this one, the place that was occupied by hydrogen will not be occupied by this alkyl group. So I come and then I turn it so that this one can come and bond here. So I have that from this side. I have H, followed by C with a H, and then the last one is H, like that. So that's the structure. It looks like that. And then what is the name of this structure? When you are drawing, you start with the alkanoic acid part followed by the alkanol. But when you are now naming, you start with the alkanol part and then you end up with the alkanoic acid part. So this one is 1, 2, 3. It becomes propyl, an alkali group, but propyl because of 3. And then this one becomes what? Propanoate. So this is the ester. The ester is propyl propanoate. Now you have the correct answer for that question. Then we go to question 2. Question 2 says what? You state the particles responsible for electrical conductivity of molten sodium chloride. We said sodium chloride is an ionic substance. In solid form it doesn't conduct, but in molten form or liquid form it conducts. The reason is because we have presence of what? They are mobile. Presence of mobile ions. Sodium ions become mobile, chloride ions become mobile in molten states. So it is mobile ions. And then for metals, all metals are conductors, both in solid and liquid, is because they are what? Delocalized. electrons. So presence of delocalized electrons are the ones that make what metals like copper to be good conductors of electricity. And then the next question says, what is an electrolyte? Which is our form 2 question. You did and what effect of electric current on substances, and we said an electrolyte is what? A substance. It is a substance in a molten or aqueous state, either molten or aqueous state that allows an electric current to pass through it, and in the process it gets decomposed. It's actually broken down by the current. So that means that if I pass electric current through molten sodium chloride allows the current to pass through, and then this salt, so this substance is broken down to sodium ions and chloride ions, so it becomes an electrolyte. So the substance in molten or aqueous state that allows an electric current to pass through it and gets decomposed. That is the meaning of an electrolyte. Now look at this question. This question is question 3. On the same axis, draw sketch graphs for reactions between 2 grams of zinc granules and 100 cubic centimeters of 1 molar HCl. You label this curve as 1, and reaction between 2 grams of zinc granules and 100 cubic centimeters of 2 molar HCl. Label this curve 2. Now look at this. That here the metal is the same, zinc granules, same amount, 2 grams, 2 grams. The difference is the acid, and the acid is the same, yes, the hydrochloric acid. The difference is what? The concentration. You can see this one is 1 molar, this one is 2 molar. So if you are 1 molar, it means then the concentration is higher. Here the concentration is less. When you have a higher concentration, it means you have more particles that can collide, and therefore there's a higher chance that you get more products. So it means when you have a higher concentration of the acid, the reaction becomes higher, so you get products at faster rate compared to when the concentration is lower. So in this case, if we are told to sketch, then you draw like that, you do it like that and like that. So do you have here, this one is what? Time. It is time. And then here it is what? Volume. It is volume of hydrogen gas, because the metal and the acid, you get a salt and hydrogen gas. So this is volume of hydrogen gas, and then this one is what? Time. And then from there, what do we have now? So I'll have the first curve is here for the first reaction, curve 1. So curve 1 is 2 grams of zinc granules and 1 molar HCl. So I'll have something that looks like that. The volume increases, and then towards the end it flattens like that. Then I call this one what? This one is curve 1. So this curve 1 is actually the curve of 1 molar HCl. And then now I draw another one. The other one is for curve 2, which is 2 molar. So because it is 2 molar, the concentration is higher, you have more particles available to collide, and therefore the reaction becomes higher. So it will be higher like that. Yeah, it will be higher. These curves will never meet. They will never meet, so you'll have that. This is Roman, you have 2 there, and then this one is 2 molar HCl. So you have curve 1 for the lower concentration, curve 2 for the higher concentration. So if you look at this one is very correct. So the concentration, if it is lower, it becomes lower here. If the concentration is higher, the curve becomes what? Higher, it will be above, like that. So that is how you will you're supposed to answer that question. You sketch it like that, and you get your marks. Then we go to question 4. Question 4 says what? The diagram below shows electrolysis of copper 2 sulfate using inert electrodes. Then you are told, you can see there's copper sulfate, there's a gas X, all that. And then Roman 1 says, on the diagram, label the cathode and the anode. So you can see the dry cells are not given, so you can't tell which one is the cathode and which one is the anode, but you can get the answer by looking at the products. This one here, this one is giving you the idea, because you have to know what is inside copper 2 sulfate solution. Inside there you have 4 types of ions. You have copper 2 ions, and then you have hydrogen ions from water, you have sulfate ions, and then you have hydroxide ions from water. So it means during electrolysis, the negative ions will be attracted towards what? Towards the anode, because the anode is positively charged, and then the positively charged ions, they're attracted by the negative what? Electrode, which is cathode. And you'll see that once they go there, these ones go to anode, these ones go to cathode. And then now from there, there's what we call preferential discharge. So out of these two, one is a preferential discharge. In this case, it is hydroxide ions that will be discharged to give you oxygen. So at the anode, you will have a gas, which is oxygen. And then at the cathode, between hydrogen and copper, copper is the one that is discharged. So it means you'll get copper solid. So at the cathode, you'll have a solid being formed, which is a brown solid. And then at the anode, you'll have what? A colorless gas, which will not be what? Oxygen. So in this case, if you know that, then you come back here and see that because one side you have a brown solid, the cathode, and the other side you'll have what? A colorless gas, which is the anode. You look at the two. This electrode is the one that is giving you what? That gas. And the gas is only being produced at the anode. So it means then, if you're told on the diagram label cathode and anode, then you come and label this metal electrode. Can you see? You touch it properly like that. This one becomes our what? Our anode. And then this one becomes our cathode like that. Are we together? So you have answered the question. And then you're told write ionic equations for the reactions at anode and cathode. Now once you have identified the anode and the cathode, then you use the same concept that I'm telling you here. The sulfate ions and hydroxide go to the anode, and then OH ions are the ones that are discharged. So you'll have, they're always 4 moles of hydroxide ions. They are released to give you 2 moles of water. This one you must get it always plus 4 electrons. It's always like that. 4 moles of hydroxide giving you 2 moles of water, 1 mole of oxygen, and 4 electrons. And then these electrons now, they come to the cathode. So at the cathode, what do you have? You have copper 2 ions that will be preferential discharged. So these copper 2 ions will accept the 4. So because you have, if I put a 4 here, I still have to simplify. You just put 2 and then you get what? That. So instead of writing 4, 4, 4, if you have a 4 here, a 4, if you have a 4 here, not 4 but 2, if you have a 2 here, 2 will give you 4 electrons to give you 2. So you'll have to simplify by 2, by 2, by 2. You still get what? 1, 2, 1. So you just write it like the way it is, like this. Copper 2 ions plus 2 electrons to give you copper metal. So this one is the ionic equation at the anode, ionic equation at the cathode, like that. And then you are told identify gas X. Gas X can only be oxygen gas, nothing else. Because now we said this is the anode, and the anode is giving oxygen, so the gas is oxygen gas. Then we go to the next. The next question is question 5. And question 5 says that using dots and crosses to represent electrons, draw structures of carbon 2 oxide, ammonium ion, and magnesium chloride. I believe that this one is very simple. So what do? You have to know that carbon and oxygen, all of them are what? Are non-metals, so they will contribute and share electrons. But in this molecule, you have both covalent and dative bonds. So what do we have here? You come and draw. When you are showing covalent bonds, we only use the outermost energy level. So you just come and show here. The nucleus is having what? This one, the element is carbon, is there. So I show the outermost energy level. Carbon is 2, 4. So the configuration is 2, 4. This one is 2, 6. So it means that this oxygen requires 2 electrons from carbon, so carbon will contribute 2 electrons, and then carbon requires 4 to be stable, so oxygen will contribute 4 electrons. So you can see that because this one is contributing 2, it means you must have what? You must have oxygen coming there, and oxygen overlaps like that, the outermost energy level. This is the nucleus. I put an O here for oxygen. Then oxygen gives 2 electrons, so not 2 but 4. Oxygen will give 4, this one gives 2 to make it 8. So I can give the 2. I give, carbon gives 1, 2, like that. If I give 2, how many are remaining from here? I give 2, I remain with 2, like that. And then oxygen, because this one is giving 2, oxygen must also give what? It is giving 4, but out of the 4, 1 will be shared there, so oxygen gives 1 there, so the other one comes there. So I've given 2, how many are remaining from oxygen? Oxygen has to give what? Another pair, like that. So you can see oxygen will end up giving 4, carbon gives 2, so that you have 2 covalent bonds and 1 dative bond. If you have 1, 2, 3, 4, 5, 6, 7, 8, carbon is okay. 1, 2, 3, 4, 5, 6, so you remain with what? 2 electrons here that are not being used, so you'll have the molecule looking like that. Carbon, oxygen, carbon 2 oxide, drawn like that. Then I come to ammonium. So nitrogen is what? 2, 5. Nitrogen is 2, 5, and then every hydrogen is 1. But now if you see a positive, it means one of the hydrogens here is an ion. It has no electrons, but it can accept 2, a pair of electrons. So it means then I'll have what? Nitrogen will be there at the center like that, and then outermost energy level is there. This outermost energy level of nitrogen has 5 valence electrons. So out of the 5, 3 will be shared with 3 hydrogens, normal covalent bonding. So I have 1, 2, 3. These 3 are being shared with the 3 hydrogens, which are not ions. So the first hydrogen comes there, so I put the hydrogen here, I put an electron there, hydrogen is here, an electron there, another hydrogen there, an electron here, like that. And then now when you have the 3, you are remaining with 2, so the 2 for nitrogen come there. The fourth hydrogen, which is the ion, has no electron but can accept a maximum of 2, so this one now is the hydrogen ion that is coming there, and then now the whole charge is taken up by the ion and is positive, like that. So this is how you draw ammonium ion, like that. Then we come to magnesium chloride. So magnesium, a metal, chlorine, and a metal, this transfer of electrons from magnesium to chlorine, so it means you form ions. So magnesium is positive, chlorine is negative, so the bond is ionic bonding. So how do we draw? For ionic bonding, you show all the ions from the first energy level to the last. So we are there. Magnesium is 282, chlorine is 287. So it means because there are 2 chlorines, these 2 electrons will be taken by the 2 chlorines, and then magnesium will remain with 2 energy levels. So the first energy level is there, having what? 1, 2 electrons. The second one has 8, 1, 2, 3, 4, 5, 6, 7, 8. And then you come there and you put what? The charge here, 2 positive, because 2 have been lost. And then now I come and draw what? Chlorine this side. The first energy level for chlorine has 2 electrons. You can see I'm using dots because these are 2 different elements. The first has 2. The second energy level has 8. 1, 2, 3, 4, 5, 6, 7, 8. And then the third energy level has 7. 1, 2, 3, 4, 5, 6, 7. So the 8th electron is coming from here. I come and put the X. The X is from here. The electron of magnesium is there, and because there are 2, instead of drawing another one similar to this, what do? I introduce a bracket. I put a bracket there like that, a bracket like that. If it is having an electron here, it is negative 1 like that. And because there are 2, the second one, instead of drawing, you just put a 2 before the ion like that. So this one is your magnesium chloride. It's supposed to be drawn like that. So magnesium, 2 energy levels, 2 plus. Chlorine, there's a 2 before, and then now you are there. So these are the 2. So the 2 means the 2 electrons. This X here, 2 electrons that are coming from magnesium, accepted by chlorine to give us what? Magnesium chloride. And this is the ionic bonding that you're talking about. It's ionic bonding, or what we call electrovalent bonds. Then we go to question 6. Question 6. Name the heat changes represented by delta H in the process below. Sodium solid to sodium gas. We said if you have a solid substance and you heat it and it becomes a gas, you're actually dealing with what? The lattice structure of the substance. So from solid to gas, the type of energy change is called lattice. So this one is lattice energy. It's called lattice energy. And then from the metal gas form to metal ion and the loss of an electron. For you to remove an electron, you must use energy. The energy we said is called ionization energy. So this type of energy is ionization energy. The other one is called lattice energy. From solid to gas, lattice energy. It will be the same thing if it is from gas to solid. It is still lattice energy. And then now removal of an electron from an atom in gaseous states. From the outermost energy level, the energy is called ionization energy. Like that. Last question. Explain. Question says explain the following observations. Atomic radius decreases across a period, and then melting point increases down group 7 elements. So for part A, why is it that the atomic radius decreases across a period? And you say this, even if you look at sodium, magnesium, aluminium, across that period 3, you will find that the atomic radius is decreasing. And the answer is because it is due to increase in number of protons. So when you move from left to right or across a period, number of protons are increased. When you increase number of protons, you increase what? Which increases effective nuclear charge. So the charge of the nucleus increases because protons are positively charged. So nuclear charge is increased. When you increase nuclear charge, it means then hence what? Stronger force of what? Attraction of electrons towards nucleus. So you'll find that as you move from left to right, as you move across a period, the number of protons are increased, the nuclear charge is therefore increased, and the force of attraction between the electrons and the nucleus becomes higher, and therefore the atomic size or the atomic radius of those elements must decrease. Then we go to melting point increasing down group 7 elements. And the reason why, if you look at fluorine, is the smallest. As you go to chlorine is bigger, bromine becomes bigger, even bigger than what? Chlorine and fluorine. And the reason is because as you move down the group, the molecular sizes of these elements increases. So it is due to increase in molecular sizes, which increases strength of intermolecular forces of attraction, which we call them, they are called van der Waals forces. Hence what? More energy required to break the forces. So as you move down group 7 elements, the family of halogens, the molecular sizes of the elements increase. So because the molecular sizes are increasing, it means then the strength of van der Waals forces increases. When the strength of van der Waals forces increases, it means you are requiring more heat energy to break the forces of attraction. That is why you'll find that the melting point increases down group 7 elements. Thank you so much. I hope this information will help you as you prepare for your Kcse. All the best and God bless you. Bye.